ANB Sensors iCal technology works. So let's start by looking at a typical glass ISE. A pH sensor works by simply taking a potentiometric measurement between the pH electrode in the glass bowl and a reference electrode which sits inside its own chamber. This reference electrode chamber is filled with 3 molar KCl solution to keep it as stable as possible and is separated from the glass bowl by a semi-porous frit. The trouble is, over time, ions can move through the frit, changing the composition inside the reference chamber and thereby changing the reference potential. So the pH value drifts in accordance with the reference potential, and the end user doesn't know if the change in pH they are seeing is a real change or just a consequence of reference electrode drift. Over the years, companies have tried to overcome this reference electrode drift by making improvements to various parts of the sensor or by writing algorithms to try and predict the drift. But at ANB Sensors we've taken a different approach. We know that we can't stop the drift as it is intrinsic to the sensor, so we've come up with a novel way to track the drift, thereby allowing the sensor to self-calibrate. This new technology is called the iCal, and it is an additional electrode that simply sits in the reference chamber alongside the reference electrode and monitors any reference electrode drift. How does it do that? It works by using a voltammetric measurement. The voltammetric signal we use is independent of ion concentration and electrolyte composition, so any changes we see in the peak potential of our iCal measurement will intrinsically tell us about the reference electrode potential. So, by knowing in real time what is happening to the reference electrode, we can correct our pH measurement to negate any influence of reference electrode drift.